Hi, everyone. So this is the video where I talk about how to analyze your data. So I'm going to go through some things in Excel, and then I'm going to go through some things in SPSS. And as I talk, I'm going to show you how to do the things. However, I'm going to do them fairly quickly. And for those of you not as familiar with Excel or SPSS, it's probably going to be too quickly for you to be able to do it yourselves. So see this as an idea of what is out there, and then you can search for a YouTube video that goes through it more slowly, because the YouTube videos that are out there, like if you search for one little thing, like how to make an average in Excel, they will go through it much more slowly and carefully, whereas I'm going to kind of go through the whole process. All right. So this is a data set from some of my prior work. And the first thing I want you to see is that I downloaded the data from the survey and I put it into an Excel sheet that I called raw data, because I want to have a record of the original data as I move through my cleaning and creating of averages and so forth. So this data has the original questions up here and then the items, right? And a lot of times SurveyMonkey at least spits it out with 2 rows on the top. So it's like, how often do your students do each of these? And then here's the individual items: make and record observations, present procedures. And notice that it downloaded the full item, all right? So if I ever get lost in my next, as I clean the data, I can always come back here and figure out what's going on. All right, then I copy this sheet by clicking this little gray arrow up here and Control-C or copy, and it'll select the whole sheet and I paste it into the next sheet, which I call cleaned. All right, that is because you can't do anything in Excel or SPSS with 2 lines up here that are your labels. You need only 1 row with your data, your variable labels. It just otherwise won't know what to do with it. So notice that when I cleaned it, I gave each item, each survey item, a label that is shorter. So see here that now this one in raw data here, make and record observations, is now called ASIP1 Prac 3 OBS, which is like kind of an annoying name, but there was a reason for it at the time. Okay, and then you see that I've actually got some of my demographic variables and things like that here. Notice also that all of the variables are now numbers, even grade span. So they might have put 3, 5. I had like a rubric for where I put them into their grade span situation, all right? Into the, because everything has to have just a clean number. Subject, I see I already turned subject into a number as well. So if it was science, it got a 2. If it was elementary credential or whatever, it was a 3. Science a 1. Sorry, I don't actually, science, math. Anyway, whatever. I had a reason for these numbers. Essentially, I turned these numbers for their subject that they teach into these subjects into a number over here. And then I had a code book so that I could remember what a 1 meant, what a 3 meant, what a 4 meant. All right. Now, once all the things are numbers, that's the first step, then we want to create averages across our constructs. So let's say that these first 3 items on the survey are a construct. And I'm just turning them blue for you to kind of have an idea of where they are. I'm going to select this whole column by holding the arrow over the column and clicking it, and then go up here to this thing that says insert, and I'm going to insert a column. Okay, and that creates a column, and I'm going to type average of whatever this construct is. Right, and I'm going to give it a relatively short name so that I know what it is. Then I stick the cursor in the first square just to the right of the first line of data, and I put equals average, and Excel kindly pulls up, you know, a little box that says, well, which one of these do you want? and it says returns the average, their arithmetic mean. So I'm going to click on that. And then there's like a little parentheses, and I'm just going to select the data I want it to average and click enter. Now, that's the kind of thing that if that was too fast, you can find a video on anywhere on YouTube to do a little bit more slowly. Now, the great part is I don't have to do that every time. I can just click back on this box where I've created the average and float my cursor over the lower right corner. And see how my cursor turns into a plus? Well, it's already a plus, but it turns into a little black plus. Like that, boop. When I double click on that lower right corner, it's going to create the average for my whole column. So it'll do that all the way down to the bottom of all of your data. So again, hold my cursor over the green box in the lower right, double click, and it's going to go all the way down. Now, it will also turn up things like this, div 0. So I just want to erase, delete that so you don't create noise in the data. In fact, I might just want to delete this whole row because that person did not fill out their survey. Okay, so then I've created my averages. I'm going to create a pivot table to compare my averages and to visualize my data. So to create a pivot table, and again, there are many videos. This is just a quickie. I'm going to select the whole data set by clicking on that little corner there. And by the way, pivot tables will not happen if you do not have a name for every single column. So if you have data in a column, it needs to have a label up above or else it will not work. Okay, so now I've selected all my data. I put insert and then pivot table. And then I select OK. And it will create a new sheet for my pivot table with the pivot table stuff over here. Okay. Now, I'm going to not go through the details of looking at a pivot table, but because there's a lot of cool things you can do, instead I'm going to skip to where they're already created. But basically, you take something you're interested in and you drag it to where you want to see it. So maybe there's my observations, or that's the average I just created. And maybe I want to look at it by grade span. And right now it's just numbers. See, it says count of average over here in the bottom. So I want to change that to average. Okay, and so now I know that for grade span 1, the average is 2.66, grade span 2, 4.1, and so forth. All right, so I know that there's some differences in the average for my construct across grade spans. And from here, I can start creating charts and graphs. So I'm going to show you what that looks like. So in this tab, I created a bunch of charts and graphs. And you can see here, this is the pivot table. I created some averages. So average of analysis, average of literacy, average of reasoning, average of traditional. So these are kinds of instruction. So if you think about traditional, that's like traditional kinds of instruction. Reasoning is like a lot of scientific sense making. Stewardship is, we were doing some environmental stewardship stuff, okay? So, and then this was the subject, like, so whether they taught science or elementary or, you know, were they single subject and they taught a single subject, or was it something else, all right? And I just started creating a bunch of, I would copy and paste these tables down below and started creating a bunch of charts, right? And so you can see here, this was by subject. This one over here was by whether they taught elementary, middle, or high school. And you can also see that I did some color changes, which you can do, but you'll need to look up a video of how to change, because when you just create a chart in Excel, it creates some pretty awful colors. So I went through and changed the colors to make it a little bit more I don't know, a little bit less garish, let's say. So as you look at your charts, you can start to think about, well, what does this really mean? Like as I look at this chart, for example, the one that is the subject area, I notice that generally stewardship integration is a little bit lower. Generally reasoning and prior knowledge are a little bit higher. I notice that if I'm looking at a particular one, like I'm very interested in how many folks said they did a lot of traditional instruction, I'd be like, oh, the people who did Science Plus and the elementary teachers did a lot of traditional instruction. If I'm interested in stewardship integration, I might notice that the Science Plus teachers actually did a little more stewardship integration, right? But the things here are actually not that interesting. Whereas when I go over here to elementary, middle, and high school, I start to see some very interesting trends, which is that elementary was lower on almost all of these in terms of the time that they spent doing these things in class, except for traditional instruction, right? So you can see that across elementary, middle, and high is the same for traditional instruction, but it's lower everywhere else. And then you can see, of course, in stewardship, there's a very big difference as well, right? So I started just playing around with what do I highlight in the data? Now, one thing I do that I highly recommend that you would do is that I take each of these charts I make, I copy them, and I open a Word doc. Which I will show you in a moment. And I'll paste the chart. And then I will write what this chart is so I can remember. So this is comparing instructional practice across subject areas. Right, and then I go back to my thing, I choose another chart. So each time I make a chart, as I'm playing with my data, I just do the same thing, right? Copy it in. Oh, the colors translated badly. So this is grade level and instructional practice. Okay, so what that gives you is even if you're not, even if it's a chart, you're like, oh, I'm not so sure about that one, it just gives you a sense of everything that's going on in your data, and then you can go in and select later what charts you're going to use for your analyses or for anything else. You also, like you can see here, I did some that were just one subject area, right? Like I had the pivot table select just the folks who put science, just so we could look at the constructs across. So what are science teachers doing, right? Oh, it looks like they're doing a lot of prior knowledge, a lot of traditional instruction, and a little bit less stewardship integration and data collection and analysis, right? So you can look at subject areas, you can compare across groups, right? I mean, essentially that's what I'm doing here. A lot of you have a couple different groups you want to compare. Maybe it's racially, maybe it's two different classes, maybe it's folks who were retained versus folks who were not retained. So that's a big thing you can do here in your pivot tables is compare across groups and look at your main constructs across groups. And you can try different kinds of groups, just like here I tried subject area, I tried, you know, what level they were at, elementary, middle, or high school. And you can see here where I'm looking through all of those different things. What does stewardship integration look like across all these things? What does prior knowledge look like, etc. So I separated them out, I put them together, I did all these different charts, and you can see that I did that actually across all of my constructs. So these are just different constructs that I had in my same survey. Now, one thing I recommend, these charts look relatively nice because I spent some time creating, there's a way to create model charts inside Excel that you can tag. I actually recommend that you don't spend time making charts look nice until after you choose which charts you want to use. So you can just use the default Excel, put them in your Word doc, and then once you decide, oh yeah, this chart's really awesome, you can make it look like this. So you can see here, I've done a lot of data visualization to like have the columns line up over one another, to put the number at the end to, you know, just have it look kind of nice. And then you can see here's another way to do it. So I was playing around with how to visualize the data. So that's kind of the first step of things. Now, after, and only after I have visualized my data in Excel and tried to figure out what's going on, I might bring it into SPSS. Now, this is not something that you have to do. Our university supports SPSS and has it available, but also there's a free one called PSPP that works similarly. You can, in SPSS, open up an Excel file by clicking that, and then you want to say file of type, Excel, and then if you have clear variable names across the top that are not too long, it will usually open. However, there's a lot of things that can happen along the way that will cause it not to open, and I won't be able to problem solve that on this video, but there's videos, of course, that will tell you the different things you need in place. So I've opened up that data set, and I'm going to run a few different analyses, okay? So some of you would like to understand if your constructs have reliability or consistency as a factor. Okay, so say you have like 4 or 5 items and you're saying that's one construct, you can generate what's called a Cronbach's alpha that says that it's essentially the idea that there is internal consistency between those items, which means that people tend to rate those items similarly and that they're not wildly out of proportion, okay? So for that, I would select reliability analysis, and then I would select my 4 items. So these were already in here because I was doing this ahead of time, but basically it just works like I'm gonna select the 4 items that I think are in a particular factor or construct. And then on statistics, I want my mean, I want my correlation. You don't necessarily have to have those things. There's a variety of things you can select. I put continue. Model is alpha. I want my Cronbach's alpha is the name of the kind of output we want. And then it spits this thing out, all right? The most important thing here is that right here, it says Cronbach's alpha is 0.645. So that's actually not super high. You're gonna want, it'd be nice to have a Cronbach's, it's between 0 and 1. It's nice to have one that's 0.7, 0.8, 0.9. Those are good Cronbach's alpha measures. And actually, I wasn't sure that the 4 items I put in there are actually part of one construct. So hopefully yours will generate higher Cronbach's alphas. Okay, another thing you may be interested in doing is a correlation, okay? So with the correlations, you do not look at individual items, you look at averages. So you can see here that I've selected my averages and moved them over. So I already did it. So these are types of teaching. So traditional, we've already talked about, reasoning, using scientific reasoning, literacy in science, etc. So these are kinds of instructional practices. And I'm interested in the correlation, so the relationship between teachers, the degree to which they do these instructional practices, and whether they have had, I'm actually going to move this one back, whether they've had other science professional development, what their overall instructional practices, if they align with their instructional philosophies, and their grade span. Because remember, back when I was visualizing the data, it looked like the grade span had a relationship with these practices. So I want to know, well, what is that relationship? And then I click on options, and sure, I want the mean and standard deviation. Exclude cases pairwise is a way of dealing with missing data. I want the Pearson's correlation, and then I want two-tailed significance. You should basically always select two-tailed. And then I wanted to flag significant correlations. So let's see what happens. All right, it gave me a correlation table. And for bonus, it gave me the descriptive statistics. So it gave me the mean of all of my variables and the standard deviation and the N, the number of people who filled it out. So it's always nice that it actually does that for me as well. Okay, so here we see the correlations are very interesting. They're the same, these two halves of this table are the same, they're mirrors. And you can also see which correlations are significant. So looking across, what I'm really interested in is this grade span piece. So I'm gonna look across the very bottommost row. So grade span is 0.419 correlated with doing more analysis in the teaching, all right? 0.419 is not that high of a correlation because it's between 0 and 1, but it is significant. And you can see down here at the 0.05 level. And it looks like it has a higher correlation with practicing scientific literacy practices, 0.561, and back to the reasoning, 0.420. But traditional, there's no correlation. 0.121 with no significance is basically no correlation. So what this tells me is that at higher grade levels, they are doing more analysis, scientific literacy, and reasoning, but the traditional instruction is about the same. All right, so that's kind of interesting, right? And also, I can cite this stuff. I can actually say in my paper that the correlation was 0.561, and it was significant to a 0.01 level. We also see that grade span is significant with science PD. So teachers at higher grades are getting more science PD, and that there's more alignment between their philosophies and their instructional practices and their grade. Like at higher grades, there's more alignment. Now, if we want to look at anything else, like it's interesting looking at the next one up. This is whether their practices are in alignment with their instructional philosophies. And you can see that there's also a high correlation here between high alignment. So their practices are in alignment with the instructional philosophies of this PD program and doing these kinds of instructional practices, which is not that surprising, all right? So you can use this table for a lot of things, and you can definitely use these numbers in your analysis when you talk about things. Okay, finally, I know some of you want to do a regression. So a regression is where you have an outcome variable. And again, this is a bit of a crash course, so you might have to have other videos. But you have an outcome variable like retention, or maybe grade. It could be binary, retention, 1, 0, like they retained or not, or it could be grade like A, B, C, D, but of course it would be 1, 2, 3, 4. And then you want to see the relationship between your main constructs and that outcome variable. So you want to see whether your constructs of interest predict the outcome variable. So does belongingness predict retention? Okay, so in my case, I want to know, does grade span, so I'm gonna move these things back so I can show you how we select them. So your dependent variable is your outcome variable, all right? And in my case, I want my outcome variable to be scientific reasoning in the classroom. And this one right here is my predictor variable. So I'm gonna look at, I wanna know if grade span predicts reasoning in the classroom. And then it asks me a lot of questions. Definitely I want the R squared. That's an important one because that gives me the percent of variance accounted for. I want 0.05 to be my probability. You don't really have to worry too much about anything else. Okay, let's see what happens. So my most important table is right here. And this gives me my coefficient, which is 0.284. And this is a linear regression. So literally this is an equation. 0.284 times grade span plus the constant equals my outcome variable, which is reasoning. But this is important right here. See the significance right here. So grade span significantly predicts reasoning. P is less than 0.05. P is 0.029. The other thing that's interesting is up here, this R squared is 0.176. That means that this model accounts for 17 or 18% of the variance. It essentially means that grade span accounts for 18% of the variance in reasoning in this data. Now, that may be way too much for you because I know we didn't cover this during class. But for those of you who want to play around with this, it gives you just a little bit of an in to play around. And you can also download videos if you'd like to get a little bit more into it. Now, you can also run a t-test in SPSS, but this data is not set up to do that. So it's under Analyze, Compare Means. Usually you want an independent sample t-test or a paired samples t-test. Independent is you're comparing two different populations, like maybe you're comparing students who are in Sankofa versus students who are in EOP. Paired samples is usually, it's the same people who take a test one time and then they take a test again. So you're seeing if there's change over time. Most of you at this point would have an independent samples t-test. So I'll let you look that up. All right, I'm gonna end here. This is a lot for you to work on, but I think that hopefully it will support you. Feel free to ask me questions, but again, looking up videos on YouTube is also a great way to go.